Hello everyone, welcome to Neso Academy. In the previous lecture, we understood VHDL entity that defines inputs and outputs only. But the question is, what about the internal circuit or where we define the internal logic? And the answer is architecture. So, today's topic is all about VHDL architecture. Now, in general English, the word architecture means study of designing and making buildings or physical structure. Now, VHDL architecture is similar. So, overall, entity means what the system is, and architecture means how the system is created. So, today's lecture is all about VHDL architecture. And in this lecture, we will cover only one topic, which is VHDL architecture. And in this section, we will see the syntax of architecture. So let's start the lecture without any further delay. Now, we have already seen that a VHDL design structure is divided into library, entity, and architecture. And in the previous lectures, we have studied the library that contains packages which are useful for designing VHDL code. Entity, which defines only inputs and outputs of a system. Now let's see the architecture. We also know the definition of architecture as architecture defines internal working that contains logic implementation. So as per definition, architecture defines internal logic means architecture describes how the design works internally. In VHDL, architecture describes the internal working of the system. Now, we all know that entity is like a black box, which describes the inputs and outputs. So, what about the architecture? Architecture is like what's inside this black box, the overall internal structure. So, architecture contains the actual logic, means architecture contains the real circuit. Now, how do we create this real circuit or how do we define this logic operation? There are multiple ways to define this logic operation. Let's see them one by one. For very first, in digital electronics, when we design a circuit, what are the basic building blocks that we use? Yes, logic gates. So, the very first technique to define the logic is by using set of interconnected components or logic gates to represent the entire system. We will use set of interconnected logic gates. Now, this structure is similar to the circuit diagram. Therefore, this representation is called as structural representation. In this, we will write VHDL code for each of these logic gates, then combine them together to create the full system. So, the first way to define the logic is by using interconnected components. Now, the second way to define the logic is by using concurrent statements. Now, what is this? Let's understand this using the same example. Here, if we want sum and cout to generate the outputs at the same time, means simultaneously. For that, we will use concurrent statements. So, the second way to define the logic is by using set of concurrent assignment statements. Now, in this, we describe the flow of data or signals from the inputs to the outputs. Therefore, this representation is called as data flow representation, where we define the VHDL code using parallel statements. So, the second way to define the logic inside the architecture is by using concurrent assignment statements. Now, the third way to define the logic is by using sequential statements. Example, if-else condition. To understand this, let's take the same circuit. Consider this AND gate. What will be the output? It all depends on the inputs. Means, if the inputs are 1 and 1, then the output will be 1. Else, the output will be 0. So, the present state depends on the previous states. So, the third way to define the logic is by using set of sequential assignment statements, means step-by-step logic. And this representation describes the behavior of the circuit. Therefore, we called it as behavior representation. So, using any of these three or by using the combination of these three, we can define the internal logic inside the architecture. So overall, using set of interconnected components, concurrent assignment statements, sequential assignment statements, or combination of these three, we can define the logic inside the architecture. So I hope you understand this concept. Now, let's see the syntax of the architecture. So, we have already seen the VHDL code for an AND gate. So, I have taken the same AND gates architecture. Now, the architecture is divided into three parts. First, we will define the architecture's name. Then, we will declare the logic operation. And in the last, we will end our architecture. Now, let's understand this syntax step by step. The code starts with the keyword architecture. Architecture keyword is used to define the name and logic of the hardware. In simple terms, architecture keyword is used to declare the architecture's name. So, architecture and underscore arc. Now, this is the name of the architecture. Now, this is flexible. You can take any name. For example, I have taken and underscore arc. This is the example of AND gate. Now, name follows certain rules and conventions. We will see about these rules in upcoming lectures. Let's continue this code. Architecture and underscore arc of and underscore gate is. This keyword of connects architecture to entity. Means this keyword of connects this architecture with the entity and underscore gate. This is the same entity which contains inputs and output of the circuit. Now, one most important thing to remember that the name of the entity and underscore gate should be same to avoid any code errors. So, overall, architecture and underscore arc of and underscore gate is. Now, the keyword is helps to initialize the body. Means is marks the beginning of architecture. Overall, the first line defines the architecture's name and connects the architecture with the entity. Now, second line starts with the keyword begin. Begin starts the logic. Means, after begin keyword, we can declare our logic operation. Now, what is the logic? This is the example based on two input AND gate, where inputs are A and B and output is Y. So, let's see the logic. The logic is Y output less than equal A and B. Now, this symbol less than equal is called signal assignment operator. that assigns the right side value to the left side. Means it assigns A and B to output Y. Now, A and B are the inputs. Y is the output. They are also called as identifiers. Now, what are the identifiers? Identifiers are the names used to identify the elements inside the VHDL code. Example, input-output names, architecture name, entity name, etc. So overall, Y means output gets the value of A and B. Now, how to tell the compiler that this logic is of AND gates? With the help of this keyword AND. So, AND is a VHDL reserved keyword, which is a logic operator. Now, this AND keyword will act like a real AND gate. So, overall, output Y gets the value of A and B, which means this line represents the logic statement. Now, what is the use of this semicolon? Semicolon is used to separate the statements. Now, we are done with the logic operation. What will be the next step? Yes, close the architecture. Now, how to close this architecture? With the help of keyword AND. So, use AND keyword to close the architecture with the architecture name and underscore arc. So, first we define the architecture name and connect our architecture with the entity. Then, we define the logic operation. And in the last, we will end our architecture. So, I hope you understand the syntax of architecture, which means we are done with this topic, VHDL architecture. Which means we are done with the major parts of VHDL design structure. But there are few more blocks inside VHDL coding. So, in the upcoming lectures, we will see about these blocks and other design units in much more details. Which means we are done with this lecture. I will see you in the next one. Thank you.